Howdy class. So today we are going to be going over the financial part of this handout. Now that we understand the exponent and the logarithm, going through this part of the handout will make a lot more sense. So if you're still iffy on the exponents and logarithms, make sure you review the last video. Also make sure you've done the homework on exponents and logarithms as well to make sure that you understand how those concepts work. It will make this part of the lecture make so much more sense if you do that. So having said that, let's move into this. We begin with capital I. What is capital I? That stands for the simple interest accrued, right? The interest accrued. And so this is going to equal P, and P is the principal. And principal is just the original amount borrowed or loaned. R is the annual interest rate. So you kind of think of R as the cost of getting money sooner. Or if you're the investor, it would be your charge for being without your money for that time. And what is that time? Well, that will be T, and T is given in years according to this formula. Now we're going to move into the value A, and A is the accumulated amount, right? It is the sum of the principal and the simple interest, and so it's simply P plus our capital I. And we already have a value for capital I. PRT is capital I, so we substitute that in. Like so. And then we can simplify this to look like this. And again, that is the equation for simple interest, no compounding or anything like that. It's just something's borrowed at a rate and then interest accrues at the end. So let's do a quick example. John borrows $500 from Jack. I should have capitalized Jack, but I didn't. Here we are. So he borrows his money from Jack for 18 months at an interest rate of 25%. How much money does John give Jack at the end of the term? Right? He doesn't just give back the $500. He gives back the $500 plus some interest. Now note, the term is given in 18 months, but it's got to be in years, right? So it's 12 months in a year, so this term works out to 1.5 years. So make sure that you are clear on that point. So in 1.5 years, that's the term. And we've got interest rate of 25%, kind of large, but then again, it's also not being compounded. So we just apply our equation. A equals P times 1 plus RT, which is $500 times 1 plus, and what was the rate? 25%. And note that for the rate, I don't put 25, I put 0.25, and say T, that's 1.5 years. And that's 0.25 per year. So you notice how the units will cancel out. All that we'll be left with is years. And just to kind of, so P, that's the 500, and we put that there. So make sure you see that. And then the R, 0.25 comes from there. And of course, 1.5 years, that's the T coming from right there. Okay, so you work that out, plug it into your calculator, and you should get $687.50. Okay, So if you notice, that's, I'm going to box that because that is our answer. Note that that is $187.50 extra, right? Why is it extra? That is the interest, right? That is the cost that John pays for getting access to $500 before he actually is able to earn it. So that's how that works. So now we move on to the concept of compound interest. So compound interest, it breaks the term up into equal periods. Usually in a financial world, it'll be breaking up into a quarter, like a fourth of a year, or by year, and quite often it is done by month. So let's go ahead and look at how this equation works. First, we're going to kind of diagram the money out a little bit. So first thing that happens is, some amount is borrowed or invested. And after the first term goes by, right, some interest accrues. Some interest will accrue, and that interest is going to be P times 1 plus RT, right? Simple interest, right? And that's just for the first compounding period, whether it be the first quarter, the first year, or the first month. So then you go on to the next compounding period, P2, and so this takes everything from like the new principal, which is P1, and it applies the simple interest to it again. I put RT, just put 1 plus R will be fine, because it's a compound period, it's 1, which is 1, so that's why we can get away with just saying 1 plus R. And note that this will be P times 1 plus R squared. So make sure that makes sense to you. And then we go again, next compounding period. Apply the simple interest. And note that this will be P times 1 plus R to the third power. Okay, and you keep going on until you get finally to the last period, and you'll get to the amount that's actually owed. And for M compounding periods, it's going to be P to the M minus 1 times 1 plus R, which is simply the original principal, 1 plus R to the mth power. And again, M equals the total number of compounds. So we want to get this A, we want to, in terms of A, so first we got to realize a few things. Since M is the number of compounds, T is the number of years, and we're going to let N equal the number of compounds per year. So that means that the number of compounds M is N times T. Number of compounds per year times number of years. And there's also one other thing that we need to take into account. This R that we were using, it was not an annual, and I should have probably wrote R sub E to stand for the effective interest rate. Right, so that is the amount of interest accrued over one compounding period. And so R effective is simply whatever the annual rate is divided by N. That's all it is. So putting all this together, the annual compound interest rate is P times 1 plus R divided by N raised to the NT. And oftentimes what people will do is they'll just find the effective interest rate and just plug that in rather than do the whole thing all at once. You can, of course, calculate this through any order that you like. Okay, so now we've got John. He invests $500 in an account that compounds monthly at a rate of 25%. How much money does John get back from the account in 18 months? So we apply our equation. All right, and so let's go ahead and highlight the numbers. So P, that's the principal. So right there. And then we've got our rate, which is 0.25. N is the number of compounds, and so that is monthly. So it's going to be 12 compounds per year. And then we finally have our term, which is 18 months. Note that's 1.5 years. And so you kind of notice that this is telling us, these two examples are telling a story. John is borrowing $500 from Jack, and he's turning around and investing that $500 into this account that has a compound interest. So we plug everything in, $500 to get this equation. And just to kind of summarize, right, we've got $500 here, 0.25 there, 12 months, 12 compounds per year. And then we finally have our term of 18 months, or 1.5 years. All right, so we calculate this through. So you get 500 times 1.020 8333333 raised to the 18th power. Okay. And then you carry that calculation through and you find that you have $724.70. So that means that he's earned $224.70 in interest. So you kind of look at this. He borrowed money at one rate, $500 at 25%, not compounded at all in the previous example. He had to pay $187.50 for the privilege of getting that $500. He turned around, invested the $500, and made $224.70. So as you can see, he made a little bit of a profit just by moving money around in this situation. And this is a pretty simplified example, but you do see people moving money around in similar ways in money markets. And so, like I said, this is a very, very simplified example. Very rarely will you find a loan being issued out where there are no payments, and particularly if it's not compounded at all. Alright, so in this next one, we will be using Microsoft Excel, but first we're going to go ahead and make a few notes. onto what kind of equations we're going to need. So we're going to use Excel for the following. Find the amount owed for a $10,000 loan with a 10-year term. Alright, so when we put this into Excel, we have our A, and that's going to equal P times 1 plus R over N raised to the NT. And so we know that this is the same as P times 1 plus the effective annual interest raised to the M. So this is how, and the reason I'm writing it out like this is how we're going to break it up in Excel. You know, where of course RE, the effective rate, is R divided by N, and M is going to equal N times T. And so you can see from A, B, C, D, E, F, G, H, and I. Started getting carried away with the alphabet there. We can see that the number of compounds is going to be varied, so we can go ahead and set everything else up in this equation. So this is going to be 10,000 times 1 plus whatever RE happens to be raised to the M. Right? That's all we can do. And then RE, we're going to set it up like this. Let's see, we said 10% interest, so it's going to be 0.10 divided by whatever the number of compounds is. Again, we're varying the number of compounds. And our number of our total number of compounds M will be the number of compounds per year multiplied by 10 years. So in 10, or I like to put the number in front and the letter afterwards, so 10N. Either statement's correct. It just looks funny to write N10 to me, so that's why I put it that way. Alright, so let's switch over to Excel. Okay, so because I am varying the number of compounds, I'm going to type an N right there so I know what goes in that column heading. The next thing I need to know is N. I'll need to know that. And I'll need to know the effective interest rate. So we'll call this, we'll put the RE right there. Effective rate. And let's see. Yeah, I'm going to put, just to kind of for illustrative purposes, I'm going to make this 1 plus the effective rate. Close that off. And we're going to put M last. You can put them in the order you want, but I am trying to illustrate something here, so I think that will be good for us. Alright, so and when all that's done, we need to find A. Alright, so let's start off with just an annual number of compounds, since that is part A. And so when you're only compounding once per year, your effective interest rate is going to be that interest rate divided by 1. Let's go ahead and state our constants over here, though. Our principal equals, and we said what, $10,000, so our rate, our annual rate, that is 10% per year. Okay, and then I am typing a space before the divisor symbol there. And what was the other known? The time. So time was 10 years. Alright, so now that we have that, let's go ahead and calculate everything through. So this equals whatever our rate was, which is over here. Divide that by our number of compounds, which is right over here. Now note we are going to be dragging this down, so we want to put a dollar sign. Right there in front of the blue one. Because if not, when you drag it, it'll go with the travel with the cell. We don't want that. Alright, now 1 plus RE, that's simply 1 plus that guy there. All there is to it. Now M, so that's going to equal whatever the number of compounds is here, a number of compounds per year times the total number of years, right, NT. Again, we put a dollar sign in front. There we go. Alright, so now we find the accumulated amount for if we're only compounding once per year. And so that's simply going to be the principal that's a constant, so put a dollar sign in front of it, multiplied by 1 plus RE raised to the n. And so at the end of 10 years, we will have $25,937 $25,937.42 accrued. That's only for one compound per year. So let's go ahead and extend this to 2 compounds per year. Bring everything down. And note that there's an additional about $500 and I guess $560 for it in you for it, so not too bad. Note that the effective interest rate is lower, and so 1.05 raised to the 20th power times the principal. That's what's going on here. Okay, and let's move on. And you know what? I want to go ahead and give you guys one more column to think about. And we'll keep that there. Okay, and so this is simply going to be this guy raised to the n. Okay, so let's move forward here. Now we do this for quarterly, so that's 4 times per year. And we just drag and drop this down and everything changes accordingly. So a little bit extra cash. It's not coming as quickly now. Next one, so quarterly, now we do monthly. So that's 12 times per year. Drag everything down. All right, a little extra cash. At the end, a little bit more interest accrued. And let's see, that was monthly, so now we're going to go weekly. We'll just say 52 weeks out of the year. Changed it for me automatically there, pretty nice. Note that little extra cash between these two, not as much as you might expect, given that we went from 12 to 52. Next one, let's see, weekly. Now we go daily. So there are about 365 and a quarter days in a year. We're just going to call it 365. 365, if I can type. There we go. Note that going from 52 to 365 compounds per year didn't result in a big change in our increase in cash. And let's go even more, right? So 365. Well, if we do this, let's see, daily, hourly, well, there are 24 hours in a day, so we just multiply that 365 by 24. So apparently there are about 8,760 hours in a year, not counting that quarter of a day. And notice not much change is going on here. And if we do this even more, if we go, okay, well, what about by every minute? The change is a fact, just a matter of change. If you forgive me if I'm making a pun there. Let's see, we've got about close to 20 cents increase by doing that extra compounds, but that was per minute. If we do per second, no change at all. And notice that this number right here is approaching what appears to be a constant. And we type that constant into there. Note that it is the same as this number here. And a matter of fact, that is we have found a definition. The definition is E, Euler's number, or the natural number. Usually you just write the letter E to represent E. E, as we've talked about earlier in the handout, very important number, and we will talk a little bit more about it in a moment here. But notice that every second we're approaching, E times, this principle, right? That all kind of comes into play here. So, point getting at is that we're approaching a number, and so this is going to give us our continuously compound interest formula. Which is the principal times e raised to the RT. A lot of people like to refer to it as the PERT equation to help them remember how it goes, but that's how you would calculate that. And again, E is just a constant. Alright, so let's consider the next example. You are considering investing in an investment account that promises a 12% a year rate of return compounded once a quarter. And we want to know how long it will take our initial investment to grow by 25%. So we're going to need to be a little bit careful with this one. So we want it to grow by 25%. And it promises a 12% a year rate of return, and it is compounded once a quarter. Alright, so let's recall our our compound interest formula. A is the principal, 1 plus R over N, raised to the NT. Now we don't know the A, we don't know the P, we just want to know how long it takes our investment to grow. So it's just the ratio of what the future amount will be divided by the present amount that we're investing. So that 25% growth is going to be inputted right there. And so once a quarter, so it's going to be 4 going on there. T, of course, is the unknown, and 12% we'll take into account right there. So let's plug all this in. So we have 1 plus 0.12 divided by 4, 4t. Alright, so now we just got to put in our account for our 25%, and it is tempting to write, oh, 25%, I put 25 right there. You might be forgiven for thinking about that for a second, but think about this. You're saying, if you leave it like this, what you're saying is how long will it take your money to shrink down to 25%? That's not what we're looking for. We want our money to grow. So it's 1.25%. So 1.25% is what we want to do here. Okay, so let's go ahead and simplify everything that we have down. And so we have 1.25 equals 1.03 raised to the 4t. Now what do we do from here? We got to take a logarithm. So we'll take log base 10, the common log, now with logs, remember they take exponents and turn them into multiplication. That's why we're taking the log, because we want to get this 4t out in front. And so we have log of 1.03, and on the left hand side staying the same. Alright, now we divide by everything except for the t, and you'll find that t equals log of 1.25 divided by 4 log of 1.03. Plug that into your calculator and you'll get a decimal approximate of 1.88 years. Now note that lands in between one of the quarters. So in this kind of situation, if you wanted to pull your money out, a lot of times they might prorate the interest that would have been earned. That's usually kind of the standard practice. But let's assume that for one reason or another that's not allowed in the contract for the account. In that case, you'd have to wait to you get more than a fourth of your money back, but in order to see at least a quarter back, you would have to wait 2 years. And so we'll just say that is our answer. So 2 years before you can pull your money out and get at least a quarter back. Okay, I think this is about enough to cover in one video. So make sure you review everything in this video, and I'll put part 3 out very soon. So make sure you understand simple interest and compound interest rates, and keep an eye on the WebAssign homework, of course. And until next time, I hope you guys have a wonderful, beautiful day.